Hi. Hello. I think how many people are here? Only 4 people. How are you all today? Okay, why? Oh, hey, careful. Alif, hari tu kan I cancel, I delete some of the apa tu yang recorded videos tu. Hilang, tak ada. No, because that day, the last night that we videoed the thing, I forgot to hang up. So it was like on for 9 hours. Then uh so so and then all sorts of things lah, tak nak lah apa kalau conversation yang tak sepatutnya ada kat situ. So tak apalah kot. Okay. Anything you want to ask me, then you Nila, ya, forward the thing. Today we are going to do McLaurin series. Have you heard of this McLaurin series?
Nope.
Ya ke?
Mendengar kat formula.
Okay. Okay. This McLaurin series, if let's say for example f of x is any function of x, then supposing supposing that f of x too can be expanded as a series of ascending power of x, then the series can be differentiated term by term. We have a polynomial, right? So we have, like, for example, let's say f of x is equal to let's, I think I share screen. Okay, let's say McLaurin series. Okay, if f of x is a function of x, okay, f of x is a function of x, and can be expanded as a series of ascending power of x. Expanded, yeah.
Manju,
Yeah.
are you sharing screen?
Oh my god. Sorry.
Okay.
Sorry. Okay, wait. Oh my god. Jahat. Okay, sorry. share screen. Start now.
Yeah. Okay.
Okay, you can see, yeah. All right.
Yes.
All right. So if f of x is a function of x and can be expanded as a series of ascending power of x, ascending power. Okay. And that this series can be differentiated term by term. Uh, uh, let's say can you have we have f of x is equal to a naught plus a1 x plus a2 x squared plus dot 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 plus a n x to the n. All right, so let's say we have this o plus. Okay, now a naught, a1, a2 and so on are constants. So if we differentiate f of x, let's say we differentiate f of x, so we get a1 plus 2a2 x plus 3a3 x squared plus so on plus uh, n a n x n minus 1 plus dot dot dot. Okay, then we get f prime of 0 is equals to a1 f double prime of 0 is equal to, we just replace x to be 0, so I get 2a2 and so on. You get f triple prime of 0, we get 3a3 and so on. Okay, hence we can deduce here and we can deduce that after differentiating f of x r times, we can deduce that let's say fr to the f to the r of 0, you get, what do you get? If we get f double prime, we get 2a2. So this one is r a r, or fn is equal to n a n. Okay, so we then get f of x is equal to f of naught plus f prime of x plus f double prime of squared divided by 2 factorial plus, sorry, no, this one is not, sorry, when we differentiate that, we get this, but we still get the second, let's say f double prime, so you get f double prime here, oops, sorry, f double prime, f prime we differentiate, you get, sorry, fx is equals to x naught. This is f prime, sorry. So you get f prime of naught, we get a1. So f double prime of naught will get correct lah. But when we differentiate, f double, this is correct, isn't it? But if we have f triple prime of let's say naught is equals to 3 a3, correct. So now but if we look at so we get f double prime is equals to, so f double prime here is equals to f double prime of 0 is equal to 2a2. This is actually equals to f double prime of 0 is equal divided by 2. Okay, f double prime. So what else can we deduce here? F triple prime of 0 is equal to f triple prime of 0 is equal to 3 here is equals to like 3 what do we call this? F triple prime of 0 is equals to, so sorry, I think I have to cancel this thing out first. I just want to work it out, the general expression of this. So f double prime, okay, I want to work out the coefficient. If we have f double prime of 0 is equal to 2a2, right? So a2 is equal to f double prime divided by 2, isn't it? So a3 is equals to f triple prime of 0 divided by 3. Okay, so what is, if you look at the expression just now, the earlier on, f of x is equal to a naught plus a1x plus a2x squared plus a3x cubed plus a4x to the 4, etc. Okay, so what can you see from here? So f of so a naught, f is going to be f of 0. Okay, and then f a1, what is a1? a1 is f prime of 0. What is a2? What is a2? a2 is equal to f double prime of 0 divided by 2 x squared, right? f3 is equals to this, and what is this thing? f3, sorry, a3, sorry, a3. Anyone? I purposely take out one step. Just work this thing out. Okay, so if you have, let's say, this is f of x, so f prime of x is equals to a1 plus a2 2a2 x plus 3a3x squared. So when you differentiate further to that, you will get, when you differentiate further, so we get multiply with f double prime of x, you will get 2a2 plus, okay, 2a2 plus 6a3 x, whoops, plus, if that one just now was 4 times 3, so 4 times 3, which is 12. 4 times 3, differentiate once, x squared. So if you differentiate another time for f triple prime, so you get 4 times 3 times 2 x, isn't it? So then you will get this thing, a2 is equals to that, a3 is equals to f triple prime divided by of 0 divided by 3 factorial. Sorry. Okay. And then we get a4 is equal to, work that thing out, f 4 times, okay, of 0 divided by 4 factorial. So that's why you will get this one is plus f triple prime of 0 divided by 3 factorial x cubed. And then you have plus f 4 factorial and so on, x to the 4. So this is what we call McLaurin series. Okay, do you follow that? Put it this way lah. Okay, f of x is equals to a naught plus a1 x plus a2 x squared plus a3 x cubed plus and so on. I think I have to add a4 x to the 4. So it differentiate f prime of x is equal to a1 plus a2x plus 3a3x squared plus 4a4x cubed. So if we differentiate another time, we get 2a2 plus 6a3x plus if we were to have another one here, it would be 5a5x to the 4. So we get 5 times 4, which is 20 a5x 3. Alright, so if we differentiate another time, we will get 6 A3 plus 24A4 plus 60, sorry. 60 A5, etc. So, A5x squared x. Alright, so we can see that if we take f prime f of naught is equal to 0, oh sorry, a naught, f prime of 0, we just put x equals to 0, so you get a1. And then if you put f double prime of 0, take f double prime of 0, the rest will be 0, so you get 2a2. And then if we take f triple prime of 0, we will get f triple prime, which is this 6a3. So that 6 is equals to 3 times 2, which is 3 times 2 a3, which is actually equals to 3 factorial. Okay, and if we take f 4 times of naught, it's going to be, differentiate this another time, we differentiate f triple prime here, we'll get 24a4, 24a4, only 24a4, and this is equal to 4 factorial times a4. So that's why we have we can express f of x as a naught plus a1x plus a2x squared plus and so on. This is equal to a naught plus a1 is equals to f prime f double prime of naught x squared 2 factorial plus f triple prime of naught x cubed 3 factorial plus f 4 times of x to the 4 factorial plus, then you have f to the r 0 x to the r factorial. Okay, so this is what we call McLaurin series. Okay, but there are times when you have a function that is not defined at 0. What are the function? Can you tell me what function that is not defined at 0? Many function that cannot be defined at 0, you cannot use this McLaurin series. Let's say for example, f of x is equal to ln x. F prime of x is equal to 1 on x. Alright? Can you have this?
No.
Cannot, right? So you cannot use. So most series can be expressed in terms of, the series expansion can be expressed using Maclaurin series, but not all. Okay, let's say for example, in this case, when f of naught is not defined, when it is not defined at x equals to 0, then you cannot use Maclaurin series. Okay, so let's say for example, you have you can have, say for example, f of, okay, we want to find f of x, example, is equal to e to the x, example. Okay, so if we have this, we know that f prime of x is equals to e to the x, and f prime of 0 is equal to, when x is 0, what do you get?
1.
1. So you have, if you use McLaurin series, we know that they are all 1. Okay, if you use McLaurin series, using McLaurin series, okay, as mentioned, we get f of x, which is equals to f of naught plus f prime of naught plus f double prime, x, f double prime of naught x squared divided by 2 factorial plus f triple prime of naught x cubed 3 factorial. So f naught is 1. F prime of naught is equal to 1 also. So you get plus x, and then plus x squared on 2 factorial plus x cubed on 3 factorial plus so on. So if, can you tell me if you have this f of x is equals to e to the minus x. Can you guess what the question would, what the answer would be? The series expansion. Hello?
Thinking, Panji, thinking.
Change the x becomes
1 over...
minus x.
Oh.
No, 1 minus x only.
Okay.
This is f of x, study 2. F of x, if I put this is as f1 of x, my f1 of x is equal to f of minus x, isn't it? So my f of x is this. This is my f of x. So f of minus 1 of x is equal to changing all that only. So this is equals to 1 minus x plus x squared on 2 factorial minus x cubed on 3 factorial plus, so x to the 4 on 4 factorial and so on. Okay. Get it?
Yes.
But if you have, let's say, and I said just now that ln you cannot use McLaurin series. But let's say, for example, you have something, let's say, f of x, f2 of x. This is equal to 1 ln of 1 plus x. This one will be in the formula booklet anyway. But just to exercise your the use of this McLaurin series. So you have f of f2 of x is equal to this. So when you differentiate, that is equals to what? 1 plus x, isn't it?
Yes.
Okay. So when you differentiate another time, minus 1 over 1 plus x
Squared.
And you differentiate again, you get f triple prime of x. This is equals to
1 over 1 plus x cubed.
ni true lah.
Yeah. Sorry.
Okay. Right, and so on. Kalau f is equals to 6 minus
Negative. Yeah.
to the 4. But when you put 0, they are all 1. Okay, so what do you think that the series expansion for ln of 1 plus x be? F of naught plus f prime of naught x plus f double prime of naught x squared 2 factorial plus and so on. So that is McLaurin series. So what do you get? What is f of naught? Ln 1. 0, right?
Yes.
Okay. F prime of naught.
Negative.
Eh, you put naught.
1.
Okay. X. Right.
Yes.
Okay. What else? So you get, then you get minus can, so you get x squared. Oops. So x squared on 2 factorial.
Yes.
Then plus x cube. Tapi, remember just now,
2.
you have 2,
Yes.
right? So
Yes.
what do you get? So 2 on 3 factorial.
Yes.
And
Minus
then this one is x4
negative
6
6.
on 4 factorial.
Oh, bukan
So,
negatif.
or negative, sorry. Negative. Okay, x6. So this one is x to the 4. So you end up with x minus x squared on 2 plus x cubed on 3 minus x4 on 4 plus x5 on 5 and so on. Right? So plus, sorry, if it is uh, minus 1 to the power of n plus 1. X to the power of n plus 1. Okay. Okay, so to the power of n on n. How do you get this thing? Because when it is power 2 here is minus. When it is even power, it is, doesn't matter lah. If you want to put that one, you put 2n plus 1 also can. It doesn't matter. As long as you get a negative. Okay? To make sure that it is negative. Oops, cannot put 2n plus 1 because that is, sorry, the odd, depending on whether n is odd or even. Okay, if you put 2n plus 1, n is 2, correct also. N is 3. No, cannot. You cannot put 2n plus 1, so it has to be n plus 1. Okay, so that is the formula for ln of 1 plus x. Okay, you can try for any other function. You can try, let's say, cos ke, sin ke. Let's say sine. F of x is equal to sine x. So we know that f prime of x is equal to cos x, and then f double prime of x is equal to minus sine x, and so on. Kf triple prime of x is equal to minus cos x. Alright, so f of x, if we take the formula f of naught plus f prime of naught x plus f double prime of naught x squared on 2 factorial, and so on. If it is sine, so f of naught 0, f prime of naught, which is cos 0, so 1, and then f double prime, you get 0, sine of 0 is 0, so then you have minus this thing, f triple prime, so you get x cube on for sine. And so on. So that is for sine. For cos, you can do the same thing. Right? So and then you have the standard series expansion. Okay, sorry, let's say if I have ln of 1 minus x, f of x. So how would you expand this thing? We had just now ln of 1 plus x, ln of 1 plus x. So what is ln, the series expansion for ln of 1 minus x?
Sign terbalik.
So we have, oops. So we are going to get from here, we just change x is equal to minus x. Just put x is equal to minus x. So, okay, so you get minus x minus x squared on 2. Right? And then minus x cubed on 3 minus x to the 4 on 3, 4, and so on. Now, also, you have to talk about when you get a series expansion here, because this is an infinite series, you stop at some point, right? After a few terms, you stop. So there must be a range of validity. So if it gets bigger and bigger, you won't be able to, if it gets bigger and bigger, you cannot stop. So you have to, when you say something like this, you are saying that the next, the later terms contribute less than the earlier terms. So in other words, you're saying that x to the power of 4 is less than x to the power of 3. X to the power of 3 is less than x to the power of 2. So what a common thing that you know about this, about a common condition that you know about this? You get a series of ascending power of x, and then you stop at some point, meaning that the later terms contribute less than the earlier terms. The higher the power of x, the smaller the value is. So what do you understand? Just as very trivial. What do you know about x?
Fraction.
Huh?
Huh? No, I don't know. I don't know.
X must be less than 1 lah. The modulus of x must be less than 1. Isn't it? That is simple statement when you have like, if you something is less than 1, you square it, you increase the power, you get lesser value, isn't it?
Yes.
So that's why. So in this case, what is the condition? Range of validity.
X less than 1.
The modulus of x. Oops. The modulus of x is less than 1. So if the modulus of x is less than 1, you have x is, can you have minus 1? Less than or equal to 1. Sorry. Now, by the way, can you have, in this case, basically this is basic things lah. Okay, basic. But can you have, let's say for example, in this case for our f of x is equal to, yes.
My another class is starting already.
Okay. All right. So, all right. Okay. I just continue with this note and then I post it to you. All right.
Okay.
Okay. So you can go for your next class.
Okay,
So
thank you.
everyone else can go for your next class.
Okay.
Okay. You want? Okay. Who else? Put your name in. Okay. Oh my God. I need to get the.
You take the screenshot first lah.
Okay. Yuan is not here. Yeah. They all. Okay. Oops. Kenapa tak